Hey, good morning, everyone. We're going to go through yesterday's problem. Now, I have been checking the view counts, and while some of you are definitely at least watching the videos, that's good. I'm not seeing a ton of work on Classroom, and a lot of the work that I'm seeing does not make me think that you've watched the other videos. So we're going to try through this one today. And if I could, in lieu of a brand new assignment today, what I'd like you to do is, can you go back through some of the assignments the last few days, maybe try one of those problems out. Even if you watch my video already, I would love to see your work. Now, the Google drawings have been a little funny. I don't know if it's messing up on your end, but on my end, the text looks really garbled. So if that's a problem for you, feel free to just copy it on a piece of paper. You can take a picture of that and upload the picture. You can, I don't know, there's probably a few other ways you can do it, but give me the work or stop by the Discord and ask me about it, and we can make this work. All right, so let's go through yesterday's problem. So in yesterday's problem, we had a quarry. So in many locations, old abandoned stone quarries have become filled with water once the excavating has been completed. While standing on a quarry wall, so here's our little quarry wall, a little boy, here's a little boy, tosses a piece of granite into the water. He throws the rock horizontally. So it starts off straight horizontally with a velocity of 3 meters per second. And it strikes the water, 5 meters away. So we know it 5 meters away. And so the question is, how high was this above the water? How far did the rock fall? It's actually kind of the opposite of the airplane problem we did yesterday. There it was, we knew how far it fell and how far it went, and we were trying to figure out how fast it was going. Well, here we know how fast it was going, so we're trying to figure out how far it fell. So yeah, let's work this out. Now, I'm going to go ahead and start filling in like a horizontal vertical table. So I've done this in one other spot. It helps me to zoom in because it makes my handwriting better. So horizontal and vertical. So let's go through this and see what we can pick out. So we don't know this, and this is how far it's moved vertically. So if I call this spot 0, that means we know it ends up at 0. So I know it ends up at spot 0. I just don't know where it starts. We do know that as it's falling, it will be accelerating at negative 10 meters per second squared. We do know that it's thrown sideways, which means all the velocity is horizontal. There's no velocity vertical. So the V naught vertical will be 0 as well. Now we have no clue how much time this takes, so we'll probably have to do that. Remember, the problems usually work. You use the information from one side to find time, and then you use the time to find whatever is missing over here. So let's see what we have horizontally. If we say that the place this boy threw it from was called 0, that means it starts at 0. And we know, that's not a B, that's a 0. And we know that it ends up 5 meters away. So we know that it ends up 5 meters away. It's not accelerating left or right, so the acceleration is 0 meters per second squared. There's no gravity pulling it left or right, but we do know, sorry, 1 second. If I can fix this, that'd be really nice. No. All right, sorry, my pad freaked out, so I got to do the rest of this by mouse, and that's that's no fun. All right, so good luck with that. We'll see how this goes. We know that the velocity to start with was 3 meters per second. All right, so if our position goes from 0 to 5 and it's going 3 meters per second, well, we can figure out how much time has passed. In fact, well, we have an equation for that. Let's go ahead. I'm going to turn off our picture here because we're going to do our work over here. Go away, go away. All right, so over here, let's go ahead and do our work. We know that horizontally, we don't have an acceleration, which means we can use the easier version of our equation. Position is just equal to Vt plus x naught. So if position is equal to Vt plus x naught, I know it starts off at 0 meters. It ends up at 5 meters. And it was only going 3 meters per second. Actually, what's really sad is me writing with my mouse is not looking much better than me writing with my keyboard, so that's always fun. Times t plus 0. So ultimately what we end up getting is that t must be 5 over 3 seconds, which is 1.7 seconds. So I'm going to go ahead and plug that down here. This must be 1.7 seconds. All right, so let's do my vertical equation now. Here we're going to have to use the accelerated equation because look, we have it accelerated. Remember, we're solving for that y naught. So y will be 1/2 at squared plus v naught t plus y naught. And this is all have to be vertical stuff because I have the mouse. I'm not putting my y's on all these things. But we can put on all the vertical stuff. So we know that the y will be 0. We know that a is -10 meters per second squared. We know that t is 1.7. And we have to square that. We know that v naught, well, it was 0, so that's easy, so that's all gone. Y naught, that's what we're trying to find. So if we can just figure out what y naught is, we're good. So yeah, here's what I'm going to do, is I'm going to go ahead and we know that if these two things add up to 0, then they must be opposite of each other. So if I can find out what this is, that must be the same as what this is, but just positive. So y naught must be all this stuff positive. Now, I don't have a calculator that I can show you on screen right now because I haven't figured out how to record it. But let me go ahead and look at my calculator and I'll tell you what I'm typing in as I do it. So I'm just going to go ahead and type in 0.5 times -10, or sorry, times -10, and then times 1.7, and then times 1.7. I end up getting 14.5. Yeah, we'll just say 14.5. Now, it does come out as negative, but if this is negative 14.5, this would have to be positive 14.5 so they could add up to 0. So I just got rid of the negative there. So yeah, it looks like our kid must have been throwing this from 14.5 meters up in the air. Now I do want to say that I know I'm screwing up sig figs. I bet you this should probably round to actually down to 14. So, you know, if I'm going to be super picky there, but I'm going to be on, yeah, like 3 meters per second. We probably should have 2 sig figs. So this should be at 14. I rounded this up to 15. We probably should be 14. All right, so again, generally the problems work is you work out the situation. You try to make sure you understand the situation. You decide what everything is horizontal, what everything is vertical, and you use one side to learn about the time, and then you use the time to then learn about the other side. Now, this is the same thing as that. Remember that ugly matrix form that I was making you guys look at for a second, and everyone's like, ugh. Well, this is the same thing. It's just instead of putting it in a big table, instead of putting it in these little matrices, you're just putting it in a big table, but it's no real difference. So if you can do this, like, this is just cooler looking if you ask me. I don't know. I do this all for the aesthetics. All right, everybody. That's going to do it for me today. I'm not feeling too hot. I don't think it's anything serious, but at the same time, I'm probably not going to be super active for at least a little bit. I'll be around though. If you want to, you can stop by and say hi. Type in exclamation Hinman into chat. I'm doing this just to annoy Caleb. So yeah, that'll be fun. But yeah. All right, everyone. Have a nice day. Stay safe.